Imagine two students walking from the same classroom to the science laboratory. One takes the direct corridor. The other walks around the playground and past the school office. They start and finish in the same places, but have they traveled the same distance? No. One student took a longer route. Do they have the same displacement? Yes, because their starting and finishing positions are the same. This shows an important difference in physics. Some quantities only need a size, while others also need a direction. Today, we will explore the physical quantities and the difference between scalars and vectors. Hi, and welcome to this lesson on physical quantities. Physics is about describing the world around us carefully and accurately. To do that, we need to measure things. However, measuring something is not simply about writing down a number. We also need to know what that number represents and what unit has been used. By the end of this lesson, you should be able to define a physical quantity and describe the difference between scalar and vector quantities. Let's begin by asking, what is a physical quantity? A physical quantity is anything that you can measure. For example, you can measure length with a ruler. You can measure mass with a balance. You can measure time with a stopwatch. You can measure temperature with a thermometer. However, whenever we measure something in science, we need two things. We need a number, which tells us how much, and we need a unit, which tells us what the quantity has been measured in. For example, we could say that the pencil is 15 centimeters long. The number is 15 and the unit is centimeters. We could say that an apple has a mass of 200 grams. The number is 200 and the unit is grams. We could also say that a race took 12 seconds. The number is 12 and the unit is seconds. A number by itself is not enough. If I simply say 15, we do not know what that means. It could mean 15 centimeters, 15 seconds, 15 grams, or 15 newtons. The unit gives the number its scientific meaning. Now let's use this idea to form a complete definition of a physical quantity. A physical quantity is anything in science that can be measured and written as a number with a unit. A useful way to test whether something is a physical quantity is to ask, can I give it a clear number and a scientific unit? For example, can we measure happiness? Not in the same direct and objective scientific way. We might describe how someone feels, but we cannot simply measure happiness using a ruler, a balance, a stopwatch, or a thermometer. Can we measure speed? Yes. For example, we could measure a speed of 20 meters per second. Can we measure temperature? Yes. For example, the temperature could be 22 degrees Celsius. Can we measure kindness? Again, not in the same direct scientific way. Kindness and happiness are real ideas, but they are not physical quantities because we cannot measure them objectively using a number and a scientific unit. Physical quantities are things that we can measure and describe using both a number and a unit. Now that we understand what physical quantities are, we can divide them into two main types. All physical quantities can be placed into one of two groups. They are either scalar quantities or vector quantities. This is one of the most important distinctions in physics. Some quantities only need a size. For example, if I say that the mass of a school bag is 5 kilograms, I do not need to give a direction. Saying 5 kilograms north would not make sense. Other quantities need both a size and a direction. For example, if I say that a force is 10 newtons, that may not give us enough information. We may also need to say that the force is 10 newtons to the right or 10 newtons downwards. the direction of the force affects what will happen to the object. So, the important question is, does a quantity only have magnitude, or does it have magnitude and direction? Let's look first at scalar quantities. Scalar quantities only have magnitude. They do not include direction. Magnitude means the size or amount of a physical quantity. At this level, we can think of magnitude as a number together with its corresponding unit. For example, mass is a scalar quantity. If an object has a mass of 3 kilograms, this tells us the amount of mass. We do not need to give a direction. Time is also a scalar quantity. If a race takes 12 seconds, this tells us an amount of time. Time does not have a direction. Temperature is another scalar quantity. If a room has a temperature of 22 degrees Celsius, this tells us how hot or cold the room is. Again, no direction is needed. Speed is also a scalar quantity. If a car is traveling at 30 meters per second, this tells us how fast the car is moving, but it does not tell us which direction the car is traveling in. The key idea is scalar quantities have magnitude only. Now let's compare this with vector quantities, where direction is essential. Vector quantities have both magnitude and direction. This means that a vector tells us the size of the quantity and the direction in which it acts or moves. For example, displacement is a vector quantity because it tells us how far an object has moved from its starting position and in which direction. Velocity is also a vector quantity. Velocity tells us speed in a particular direction. For example, 20 meters per second describes a speed. However, 20 meters per second north describes a velocity because a direction has been included. Force is another vector quantity. A force of 10 newtons to the right is not the same as a force of 10 newtons to the left. The magnitude is the same, but the direction is different. Acceleration is also a vector quantity because an object accelerates in a particular direction. The key idea is this. Vector quantities have magnitude and direction. One of the clearest ways to understand the difference between scalars and vectors is to compare distance and displacement. Distance is how far an object has traveled. It is the total length of the path taken. In the image, the dotted path shows the complete route traveled from the starting point to the finishing point. Distance includes every turn and every part of the journey, as shown in the blue dot. Because distance only tells us the total amount of ground covered, it has magnitude but no direction. Distance is therefore a scalar quantity. Displacement, however, is different. Displacement is the straight line change in position from the starting point to the finishing point, including direction. In the image, the starting orange arrow and dot represent displacement. Even though the person may have traveled along a long and winding route, the displacement is simply the straight line connecting the starting point to the finishing point. Displacement has a magnitude because the length of the straight line can be measured. It also has a direction because we need to say which way the finishing point is from the starting point. Displacement is therefore a vector. Remember, distance is the total length of the path traveled. Displacement is a straight line change in position from start to finish, including direction. Now let's bring together the main ideas from this lesson. Let's summarize what we have learned. A physical quantity is anything in science that can be measured and written as a number with a unit. Scalar quantities have magnitude only. This means that they have a size or amount, but they do not include direction. Examples of scalar quantities include mass, time, temperature, and speed. Vector quantities have both magnitude and direction. Examples of vector quantities include displacement, velocity, force, and acceleration. As we continue studying physics, this distinction between scalar and vector quantities will help us describe motion and forces more accurately.